Hello everyone, and welcome to yet another ZettaScale webcast. So today I have the pleasure of having with me hosting this webinar, Salva Rodríguez, which is Head of Product Management at TTTech Auto. We'll be going through some very interesting topic relating to automotive market, software-defined vehicles, and the role of communication in that world. So Salva, please tell us a little bit about yourself.
Well, first of all, thank you, Angelo, for having me, and it's a pleasure to be doing this with you. So as you have already introduced, my name is Salva Rodríguez. I'm working in TTTech Auto. I'm located in the beautiful Vienna. You have behind me the Technical University of Vienna, so we are pretty close from where the overall TTTech was founded. And I have been working since the beginning in the automotive industry, so I'm having the pleasure to start my professional career in the automotive industry and keep going, and now with TTTech since already around 9 years. So it has been a really quite of a ride.
Okay, thank you, Salva. And I'm Angelo Corsaro, the CEO and CTO for ZettaScale, for those of you that don't know me yet. Okay, so I suggest we actually get into the topic of today's webinar. So, Salva, maybe you can share your screen and we can get this thing.
Definitely.
So buckle up the seatbelt. We are starting up.
Great. So, as you know, the topic of today is talking about DDS. What is the work that we are doing? TTTech Auto jointly with ZettaScale. We'll speak a little bit later about what is the partnership about and what we have been working in the last months. But first of all, what I would like is always I'm actually a believer of starting with the why. So at the end, everything that we are doing needs to answer a why. That's why one of the strategic themes, or one of the themes that I wanted to cherry pick, is the topic of complexity and how the overall complexity is overwhelming the automotive industry. So I will speak a little bit about what does it mean complexity to us. What are the implications of those complexity traumas, so to say, for the industry? But a clear statement that I want to make is that today the overall automotive industry is facing that problem of complexity, software complexity, and that has a clear impact in what is meeting SOPs. And those meeting SOPs, or the lack of meeting those SOPs, is definitely impacting our customers and the overall industry on facing huge excess of cost in the overall programs. And this is one of the things that we will then go down the path to make all the connections about how a technology like DDS and the job that we are doing together with ZettaScale is helping us on solving this issue that the overall industry is facing. When we talk about complexity, so complexity can have different levels. So complexity for application developers might differ than the complexity from a system integrator. So what I would like to talk is about the two main vectors that today we are seeing with regards to what is moving the complexity. And usually, pretty often, we might identify that the complexity disappears or the complexity gets reduced, but in fact, the complexity moves. So before, when we were talking about a decentralized architecture that's driven by the overall E evolution, we were having troubles on connecting all those different boxes coming from different suppliers and making all those boxes working together. And now the overall automotive industry is going more towards a domain control unit, accommodated in a sort of a zonal architecture, and eventually we do have the overall centralized architecture as a lighthouse that we would like to achieve. When we talk about that from ECU to DCU, what we are seeing is going from one microcontroller to SoCs. Those SoCs, they are having multiple cores, they are having hardware accelerators, they're having, in order to be able to interconnect between each other, high-speed communication backbones. So we have gone from Ethernet. From Ethernet, we are moving towards PCI Express now. And as well, what we are having a merge between signal to service architectures, and at the end, eventually, all those things, they need to be under certain timing, qualities, and properties at the system level, being the system from the SoC to the domain control unit to the vehicle level. And eventually, once we go towards that centralized domain, what we will have is that complexity moving within higher SoCs with a certain virtualization capabilities, that eventually what it will imply is that the complexity that we were dealing with before in that overall multi-ECU and distributed system will move, and it will get into a different form of complexity, but eventually it will be complexity and integration of applications. This is what we are having today in a domain control unit. A complexity driven by having different types of applications, from safety related, non-safety related, that will need to be compliant with the overall ISO, fulfilling freedom from interference as an example, and eventually to have a safe environment that enables us to execute and to communicate applications in a proper manner. So this is from the overall driving the EE evolution, or the vector that it drives complexity driven by EE evolution. And then what we have is the overall software-defined vehicle era. What does it mean? What it means, software-defined vehicle, is to be able to accommodate different innovation pace, with regards to software and hardware. And as well, we do not have anymore a start and a stop of development, but rather we do have a continuity of development. So an application will be created, will be deployed in the car, but there will be a continuous improvement in the car, or a continuous improvement of that application that eventually needs to be done, keeping those safety and security integrity levels to the higher standard. So when we put all those things together, eventually what we are facing is that overall complexity that now is being seen since some years in the area of middleware. So some years ago, when we were talking about middleware, that overall segment was not well segmented or well identified. And now the overall industry is acknowledging the topic of middleware. It can be seen as well as pretty often OEMs are referring to it like a car operating system, even though that can have a broader scope. But basically, we have a middleware that is getting certain relevance among all the different functions or different applications or different domains. And what we have on the right side is the overall efforts on integration, validation, and verification. So at the end, what is happening is that efforts in integration, and validation, and verification, they are increasing. And one of the ways that we have to accommodate that overall complexity is by having that middleware layer in order to be able to span across the different SoCs or the different ECUs. And we need to have all the ingredients in that middleware layer in order to be able to have those integration, validation, and verification efforts under control. And this is what we'll talk on the course of the talk today, about which are those ingredients that we are working together in order to be able to have it under control. Another way to take a look to complexity is with regards to the explosion that we have had in the last years in terms of hardware resources. What you can see in the screen is a representation of a mass production program that so an architecture that you can buy a car that embeds that architecture. And then eventually today for advanced driving assistance systems, we are having domain control units that we need to handle up to 46 CPU cores. We have hardware accelerators. We do have as well networking devices, and we have as well software demands. And those software demands are in terms of number of applications, a number of executable entities, as well as system constraints. So we need to put certain constraints in the overall application landscape in order to make sure that the system can be integrated. So at the end, we cannot have a system that is free running only. We should be able eventually to integrate that system. And this is the most important thing, because if we do have, or we do create a system that it cannot be integrated, it's when we are eventually having those problems in terms of integration, validation, and verification. Eventually, those problems are being seen pretty close to SOPs, and therefore impacting SOP deadlines and having a clear direct impact in the OEMs by not being able to sell those vehicles. So this is one of the overall challenges that we have in the area of software-defined vehicles. So software is extremely complex. Making that integration of those overall software of all those different applications in a heterogeneous landscape of semiconductors, being able to abstract that semiconductor towards the application layer, as well as to make sure that we have all those properties that enable us to have a system with certain properties like real time, like determinism, etc., are one of the main challenges that today we are seeing the industry is facing with. And as TTTech Auto, as well as TTTech Auto together with ZettaScale, we are committed to solve those. We will talk now about the solution in a wide level fashion. Then we'll go to Angelo, and Angelo will dig more into the detail with regards to what are the specifics of DDS that we are doing or we are using in order to make sure that that overall dish is properly cooked in order to be able to have the problem solved. So first of all, we need to keep our users in mind. So usually in automotive, what we are having is the system integrator role. The system integrator is seeking for certain properties and qualities for the overall E architecture or the overall system, better said, like robustness, integrability, predictability, and to have that fast validation and verification. That's extremely important. But at the same point of time, we do have the software development teams, application development, and this is growing in terms of quantity, that they need completely different qualities and completely different properties. That person is seeking for having a nice and neat user experience. They want to have fast development loops, and they want to have fast feedback loops. They want to have flexibility. They do not want to deal with time constraints that the system integrator might impose into them. And they want to be as much as possible abstracted from the underlying hardware. So they shall be able to develop, for example, in the cloud, they shall be able to deploy it in the edge, back in the cloud, and so on and so forth. Therefore, is how we can have those two different roles happy using modern techniques. So we need to break with old ways of developing software, but making sure that at the end, the overall automotive is a system challenge. So at the end, we are putting that piece of software in a car, and at the end, we do need to make sure that that piece of software and those applications are running under certain conditions within certain given properties. Therefore, service-oriented architecture, so this is a term that usually is being used in the automotive industry generally. It's an imperative. So this is something that we strongly believe that is needed in order to be able to unleash that innovation and to unlock the topic of software-defined vehicles. So this is clear. But a clear statement from our side is that service-oriented architectures without control will worsen the software-defined vehicles challenges. So at the end, we cannot have service-oriented architectures without taking care of those two different roles. And a couple of things that then we'll go more into details. So as I have mentioned, we need to quantify or better qualify those end-to-end properties or those end-to-end timing properties. So when we talk about communication, and we have applications that they communicate between each other, exploiting DDS, for example, as a communication mean, we need to make sure that we give them properties or we give them capabilities to the users in order to be able to classify that channel of communication under a certain end-to-end property. So definitely not everything needs to be under that property, but everything that is under the basket of safety, we need to make sure that that's happening or that is, so to say, shielded. In addition to that, it's not only a topic of safety, but as well, in order to obtain that predictability and eventually to be able to have that integrability on the system, those properties are definitely needed. And then on the other side, what we have is the development phase versus the production phase. Pretty often, automotive players, we have been pretty focused in the area of mass production. So all our systems that have been designed to make sure that those systems can be deployed on the road. But what we are shifting now due to that overall continuity in software development, and I have mentioned before, we need to as well to embrace more relaxed manners or relaxed ways to enable software development to work with the overall platform. So in here is what we are talking about, those learn and first capabilities, and what we mean is to be able to provide flexible behaviors during development, but to provide assisted functions to the overall software development teams to freeze the overall behaviors automatically as soon as we are reaching SOP timelines. So basically, the key takeaway that I would like that you all you take with you is that SOA is here to stay. TTTech Auto is embracing it, and that's why we did the overall partnership with ZettaScale. But what we believe is that SOA, it's not enough. So we need to put certain ingredients on top in order to make it properly into automotive. And this is basically what we are working together with Angelo and his team. And what TTTech Auto has bet is on DDS as a technology foundation in order to be able to bring that into life. So with this now, Angelo, I pass it on you.
Okay, thank you very much for setting the stage, Salva. So let me share my screen and we'll continue with this nice introduction with a follow-up. So my screen should come in a moment. I think you should be able to see my screen. I'll wait couple of seconds more, and I hope that we have compensated latency and that everyone can see my screen. So once again, Salva, thank you for your very nice intro and setting the context of the challenges and the problems that there are today in the automotive industry, and how actually communication software can play a major role in addressing some of those challenges. Okay, but before getting there, as we mentioned, I want to provide a little bit more context and information on ZettaScale, because obviously we are a relatively young company. We spun off almost 1 year ago. We are very close to our first year birthday. And again, we were spun off with a mission. The mission was making sure that we could remove any kind of constraint in the way in which anything connected to a network can communicate, compute, and store. And so make it possible that, once again, communication, computation, and storage can happen anywhere, at any scale, efficiently and securely. We are a team of hardcore technologists and people that have been working in distributed system and protocol since, I would say, they were kids, or perhaps when we were very young kids, we were dreaming on working on this, and then our dream became reality, and we could work on what was our passion as a young computer scientist or a young student. But getting to our partnership with TTTech. So TTTech is actually one of our two investors. As you know, our team spun off from ADLink, again, in just about 1 year ago. And TTTech joined as a strategic investment this adventure. And the reason why we joined was because we could see in the technology that ZettaScale had been developing, okay, a solution for some of the key problems that you have today in automotive. And today we're going to discuss about one set of problems. Maybe I will give some references to other challenges, as we'll see in the next slide, that we plan to address. But again, let's focus as of today on DDS. So besides having TTTech as an investor, okay, and a strategic investor, TTTech is also an industrial partner. And as Salva mentioned, we are really putting together our expertise, our technological DNA, our savoir-faire, as you would say in French, in order to come up with solutions that address precisely the problem that Salva has been outlining so far. And in that context, we are bringing to the market the first European ISO 26262 certified DDS implementation and certified to ASIL-D, and also working on bringing into the automotive next generation V2X technology based on Zeno. But again, this is not necessarily the subject of this webinar. Today we'll focus on DDS. Now, ZettaScale is young, but let's say that has not gone unnoticed, because was just a couple of days ago, there was a startup observator that came up with a ranking of the 10 top vehicle-to-everything startup to watch in 2023. And I'm really proud that ZettaScale is one of the few European, depending on how you define Europe, okay, but between the 2 or the 3 European company in this list, okay, which is, I think, a proof of that the level of skills, savoir-faire, and how innovative we are, especially with the new technologies. So we have 2 technologies, obviously DDS, which is the subject of today. And as you know, the core of our technology is available as open source. Why? Well, because we are for open innovation, We want to make sure that technology can be adopted with zero barrier, and then eventually, obviously, we need to have a viable business behind. But again, that should be started out of adoption. With respect to Cyclone DDS, as of today, what we see in the market is that we consistently see the most performing DDS implementation in real-world deployment. By the way, if you want to hear more about what I think in terms of benchmarking and how you should run benchmark, please take a look at the Genesis webinar that we did a couple of months ago, in which I explain why you should be running a performance benchmark, in which I explain why some of the synthetic performance benchmark aren't necessarily significant for your system, right? And what are the things to watch out when you look at numbers provided by vendors. And this is one of the reasons why we typically don't give you the fish, right? We give you the tools to catch the fish, which we think is far more powerful. So we typically, with all of our product, there are batteries included, we give you all the tools required to characterize performance in your environment and with a workload that makes sense for your application, because that's the only thing that is really meaningful, okay? And in general, under those situations, we always come up on top of any other competitor, okay, in spite of the wonderful graph that they might be showing. We are the fastest growing DDS implementation for ROS2 based robots, and very strong momentum in automotive, as Salva just mentioned. Besides Cyclone DDS, we have another technology called Zeno. Zeno is a next generation protocol that expands and builds upon the experience, over 20 years of experience that we have in DDS in a distributed system, and unifies data in motion, data rest, and computation. So in short, because again, that's not the subject of today's talk, but Zeno is a single platform that you can use at the same time for doing pub/sub, distributed queries, and distributed computation in a single stack with a super small protocol that is high performant and very well efficient. But let's get back to DDS, and let's focus on automotive and DDS. So as Salva was mentioning before, the automotive industry today is suffering in a way from the rigidity of the communication technology that are used in production, and how this technology affect the flexibility that is required during deployment. And the way in which, one way, at least, let's say, the way in which I look at it, it is obviously, if you're going to deploy and if you're going to design for a mission critical system, you need determinism, as we will see. And you need determinism in several dimensions. You need temporal determinism, you need space determinism. And determinism usually means knowing everything, okay? So obviously, when you're about to deploy and you're ready to go operational, you know everything. Under development, well, it's rare that you know everything. And even if you think you know everything, sometimes you realize that that was what you thought. And eventually, especially if you're following some spiral development process, you refine your understanding of the system that you're building. And so you see that inherently there is a tension between the rigidity in a way that is required in order to build safety critical system and the flexibility that is desirable in order to have an agile and productive development process. And if you're going to certify system, most of the time, what matters the most is the fact that your system is safe, it's real time, it's predictable. So the rigidity of the resulting technology impacts the development. And perhaps that was okay up to a given complexity level. But as Salva was explaining before, and I think the point he made is just incredible. 24 million per day, 24 million euro per day of delay on an SOP platform. I couldn't believe that number, right? It's just incredible. And this is in part a consequence of the brittleness and the rigidity of the technology that are used today and the consequences during development. Again, Salva mentioned about signal-oriented design, right? Today, you can imagine a software for a car like being literally spaghetti, right? With spaghetti representing point-to-point signals. That's very hard to, it's easy to visualize, but very hard to maintain. And imagine making a change there during development. It's very messy. And this is one of the area that is creating problems, okay? So once again, there is obviously a tension between and balancing this rigid versus flexible, but I would say that today the balance is completely on making sure that we have technology that are good for deployment, allow us really to control everything, temporal determinism, resource usage, and then we penalize the development, which is quite problematic, as I've just expanded, and I think Salva provided various points. And this pain was one of the reasons why the automotive industry started looking at DDS, right? Because DDS is quite the opposite. DDS, which is a technology that was standardized actually for application in aerospace and defense, and originally really for military system, it was just about dynamicity, right? Because if for a moment, imagine a ship, okay? On a ship, you have to survive and you have to maintain your ship operational in spite of potential partial failure that could be caused by some operational failure or perhaps some attack. So DDS was designed for a world in which everything was dynamic, okay? So DDS is a technology that has dynamic discovery. So the communication paths are automatically set up. It's almost the opposite of how you design the technology for then deploying operationally, okay? And so I think that was one of the appealing aspects, because if you use DDS and use its dynamic feature, the development phase, it's quite enjoyable and quite straightforward, right? Things find out each other, you don't have anything to configure, it's quite nice. And I think, obviously this dynamicity was very appealing for development. I would assume that they had some concern with respect to deployment, but perhaps were reassured because DDS was used and is heavily used in military vehicles and a lot of mission critical application in defense and aerospace. And I think this is what eventually brought to the adoption of DDS within the AUTOSAR standard, which I'm pretty sure all of you are familiar with, and specifically with the mapping of DDS within the ARACOM, which is the communication layer of AUTOSAR Adaptive. Now the question is, okay, are we done? Then have we solved all the problem of the automotive industry? Because now we have a mapping in AUTOSAR to DDS. You take a DDS that is certified and you are done. Well, if we would think so, we would have, the webinar would be over. But the reality is that we isn't. And whoever tells you that we are, I don't think has either thought it thoroughly or maybe is underestimating the problem. Now, if you think about DDS, right, all the features that it has, they are great during development, but they are way too much during deployment. And especially all the dynamicity that exists in DDS, it's rather problematic if you need to certify and during operations, right? And so in a way, today you have solutions that are used in automotive that are on the inflexible and rigid side, and DDS, it's very good for the kind of feature you want for development, but then if you take it as is, it might be problematic for addressing the non-functional properties that you do require in an automotive system, okay? And again, you need a deployment time, you need determinism with respect to temporal behavior, you need determinism in space. That means, I need deterministic behavior for network communication, I need deterministic scheduling, and I need a way of, knowing exactly how much memory my system is going to use. And so this is one of the areas where TTTech and ZettaScale are working together, innovating together, and trying to reach perfect balance. What is perfect balance for us? Where perfect balance for us is a DDS implementation that gives you all the advantages that relates to the dynamicity that you can leverage during development, okay? But at the same time, right, as all the feature required to ensure temporal determinism and spatial determinism at deployment time, okay? And again, the only way in which I think such a DDS implementation can be built is by putting together the knowledge, the understanding, the expertise, and the savoir-faire of TTTech, Auto, and ZettaScale. Why? Because we are communication protocol expert, they are automotive expert, and by putting our knowledge and experience together, that's the only way that we can come up with something that unify the best of both worlds and reach that kind of perfect balance. So we're building this on top of an open core, because once again, our solution for automotive is based on Eclipse Cyclone DDS and will be interoperable with Eclipse Cyclone DDS. Cyclone DDS, as many of you probably know, is a project led by ZettaScale, and it's ROS2 user favorite implementation. So another advantage of Cyclone, we see some kind of, I don't know if to say convergence, but it's like when two big animals start smelling each other, right? If you can, if you like the parallel. But the point for sure, the DDS community, the ROS community and the AUTOSAR community are looking at each other, and there are more than one people or more than one company trying to understand how these two ecosystems can actually be blended together, or can integrate, or can, to some extent, work together. And obviously, the fact that we are so embedded in ROS, and the fact that we are bringing the best DDS implementation for automotive, it's yet another advantage that you can leverage when you use our product. Then going a little bit more into the specifics, with respect to temporal determinism, we are working, or well, more than we're working, what you will have in our certified version are essentially two key properties, which is, number one, integration with TSN to have temporal determinism for communication across the network, and then support for deterministic scheduling. Once again, I would like to make sure that all of you that are not necessarily familiar with TTTech Auto, okay, TTTech Auto has mastered, and one of their key IP relates precisely to scheduling, real-time scheduling, task scheduling, and this is one of the area where I think we are doing some interesting co-innovation. So once again, once you have deterministic scheduling within the host and deterministic scheduling across the network, well, you can really build a real-time system that has predictable properties. And you can only build a proper real-time system, I would say hard real-time system, if you have this mastery. Otherwise, you kind of cross the fingers, okay? Because recall, real-time isn't real fast. Real-time is predictable. And the big problem of real-time is priority inversion, okay? So if you address real-time by throwing sufficient resources, one day you might get a priority inversion, and that day, you might get in trouble, okay? So this is not how we build system. This is the kind of system we will support, right? For you, you will be able really to leverage temporal determinism at the network and task scheduling level. But that's not enough, right? Because you need real time, but you need full control over resource usage. And that's a tricky subject because in DDS, you have dynamic discovery. Like dynamic discovery makes it very hard in a way to bound the memory that you use. So in order to compensate that, we'll support fully static discovery. And there are plenty of other areas where you want to make sure that you are able to absolutely bound and predict the amount of memory that is used. And so with our certified version, you will have a way of controlling exactly how much memory your system is using, and making sure that that's a contract that will never be violated at runtime. And so, as I was mentioned before, by means of this, you will have a single API, right? Which is what you will be the contract between our technology and your applications, or if you're working on top of DDS, or perhaps you will see the AUTOSAR Adaptive APIs. But in general, you will have one single set of abstractions, right, that are very dynamic, they are service-oriented, okay, that you use during development. And once you're ready to deploy, okay, it's like if you take a snapshot of the system, use that information to configure our middleware so that now it can become rigid like like when you propose a frame, right? This is exactly what I want. Okay, and at that point you have the configuration. There is a static configuration that you can use to deploy your system. Besides that, as I was mentioning, we will have a certified version of DDS based on Cyclone DDS Q1 2024. Okay, and again, this is the collaboration with TTTech, and taking state-of-the-art approach to do this. And last but not the least, right? As for those of you that are familiar with our other technology, once you will have DDS in the vehicles, if you want to do V2X, you will be able to leverage all the Zeno platform to do that. And you will be able to leverage the Zeno platform to do even more than that, okay? But again, we'll probably cover this in some follow-on webinar. I just wanted to give you, some spice or some reference for additional things that can be unlocked once you have DDS in the vehicle. So in summary, ZettaScale and TTTech Auto are working together to bring flexibility and determinism to automotive platform. And we think that this is one of the key ways to reducing the development effort on one end and bringing agility and hopefully making sure that delay can be avoided or at least shortened, because as you saw from Salva's presentation, the impact of a day delay in an SOP is just devastating. And part of it comes from the brittleness of the technology that we use today. So this is what I wanted to cover. So I will stop momentarily sharing my screen, and we will go on Q&A. Okay, so please, if you have not done so, feel free to post your question on the chat. We'll go through it. Okay, so Salva, we already have a question for you. So the question is, could you expand the role of SOA and the impact of SOA into automotive?
Okay, so I will stay close to the mic because then I have seen that perhaps my audio was not good enough. I was indeed not taking a look to the chat. So as I mentioned before, so SOA is here to stay, and this is an imperative. So SOA is something that is not new in automotive, so it's taking a little bit more of time. So at the end, is getting started being used by different OEMs. I would say that perhaps was Adaptive AUTOSAR the one that they started with that imperative. And as well, on the other side, what it was the most the vector, so to say, to adopt that technology was as well the explosion in terms of applications. So the explosion of software developers. And at the end, one of the most important thing is how do we enable to have a distributed development environment, but still making sure that those different bits and pieces that are being developed around the world can be integrated. And this is one of the most important things. So for example, Adaptive AUTOSAR, based on our opinion, is not leveraging the full fledged service-oriented architecture design, mainly because still we do rely on centralized manifest. We do still rely on centralized gate weighting towards a signal world. And this is one of the things that definitely, based on our opinion, the industry is having problems in order to be able to have that full-fledged adoption, or let me put it another way, to realize or to sense the real benefit of what SOA will bring. And this is one of the things that TTTech Auto is committed to fix by providing, as we have been talking around in the last 40 minutes, in providing that flexibility during development. So at the end, we cannot go during development times asking for average execution times, for example. This is not valid anymore because they do not know it. But those are eventually needed at a certain point of time. And what we are working is on techniques that enables the user to provide feedback with regards to which are those average execution times, which one are those communication relationships between applications that might be subject to an end-to-end property. So at the end, what we want to do is, instead of having that monolithic system model or system manifest, to be able to generate that system model in order to be able to make sure that we can integrate that system. But still, we need to be loyal to the topic of enabling development teams distributedly working in an automotive platform.
Okay, thank you, Salva. So there is a question from Sven, I guess, for both of us, and I'm not sure. I mean, we have all the details, and perhaps that deserves a discussion. But as he asked, I will share. So Sven is asking how much it will cost. I would say less than $1 trillion for sure. But jokes apart, and then so obviously this is something I think we can discuss offline. But then yes, a follow-up question that says, will the price be connected to how many vehicles are sold, and how does the licensing model look like? So I think these are worth a follow-up, but then, I mean, in general, you know, it's usual that the licensing the license cost is tied somewhat to volumes, but I think it's worth a follow-up, Sven. So we'll follow up, and maybe Salva, you can follow up. We can follow up. We can discuss that. Okay. Then a question from He, which is, do we have an administrator tool for deploying DDS? I think it's probably even displaying how many topics there are in DDS, monitor domain, and so on and so forth. Well, the short answer is yes. And I think that the longer answer is that yes, and we'll make it possible for you to do that from anywhere on the network. Meaning, suppose you are a tier one, and there is a car, you know, in one of on the other side of the world, and you want to securely monitor what is happening on the network, on that car network. Well, we will allow to make it to do that. We cannot show that tool now. We will have a dedicated webinar, but stay tuned. I mean, that will be, those kind of tools will be demonstrated in the June timeframe, so roughly in 1 month. Okay. So there is another question from Zhang asking again, what is the business model?
Let me clarify. So at the end, I guess it is something that at the end we can state. So from on our side, our overall business model usually follows a royalty business model. So at the end, it scales up with the amount of vehicles, definitely, but there is a price per deployment, so to say, and as well there will be a license for the overall tooling. So we don't need to delay the answer.
Okay, great. Thank you, Salva. Good question from Angelo, not me, another Angelo. Okay, I think it's Angelo Greco. Hello, Angelo. So the question is, will this functional safety rigidity affect some capability to make software updates over the air? Won't we need flexibility and automatic discovery in the vehicle to update, for example, one service at a time, and so on and so forth?
Do you want to take it, or?
Well, I can take part of it, and maybe you can take the rest of it. So I think, Angelo, there will be different domains in the car, and some domain will be completely rigid, other will introduce some level of flexibility. And one of the trends, at least that I've seen, is that people would like to mix the two. So I think if there is a TSN network, that's one of the key ingredients to be able to mix the two. So, and in fact, the combination of TSN with proper hypervisor could be the interesting approach. So indeed, we are seeing different domains, some domain that historically were between quotes rigid, requiring some more dynamicity and supporting this kind of online updates use cases. But I mean, at least based on my experience, that apply to all the domains. Salva, I don't know what you want.
I want to comment on that. So at the end, the topic of so our opinion is that anything that is subject to a safety domain, it will be offline, so to say, freeze, and there will be an update. That update can be a partial update of the overall platform. but that everything will need to be frozen at design time, prior deploy time. We do not foresee any sort of dynamism in anything that is safety related, but then it can happen at any other unit. And as you have mentioned, hypervisor is one of the techniques, to be able to have a certain, to claim certain freedom from interference, might be used, to be able to have those different, more dynamic or flexible. It's better calling flexible than dynamic over there update, so to say. But the overall, the long-term promises in terms of having a much more flexible over there update in order to be able to, for example, I can now start dreaming on having an application that I download, that application exploit a quality of service that of DDS in order to be able that we can have certain properties, and at the end during runtime we see whether those properties are being fulfilled or not. This is something that we do not see anytime soon, and perhaps even though we do foresee those use cases, we leave it by the end of the second half of this decade or even beyond. And this is something that what I can tell you is that this is something that we do have internally in a strategic thing that is called making the long-term SOA promises true. So we know what it needs to be done, but we just need to wait to have the, we need to wait until we see the real use cases and we have the proper time. Just one thing, Angelo, because I see that you skip one question that is regarding China, and the question is whether we have enough resources in China to support DDS integration. And just don't want to miss this. So we are pretty active in China. So I have had the chance to be in China twice after everything got open. So in China, we are TTTech Auto has its own entity. In that entity, we are having our own resources, and as well we are working a partnership with different local entities, with different tier 1 or tech companies, that at the end we will have definitely local support for China.
Okay, thank you. That was in fact the next one we're supposed to hit. Great. Then there are lots of questions. We'll keep going, okay, because we still have time, and it's good to see that there are so many questions. Okay, so the next question is Cyclone DDS developed based on open source one? So Cyclone DDS is the open source one, and let's say that our certified version is based on the Cyclone DDS, which is open source. Obviously, there will be elements that won't be open source, but the certified version will be interoperable with the open source. There is another question: does your DDS supports the priority, the transport priority, DDS transport priority QoS? So short answer is yes. Longest answer is, well, if you know well the DDS standard, the transport priority is just a hint, okay? So most of DDS implementation support the API level and then just take it as a hint, which means do nothing, okay? In our case, that number is also used to impact the actual communication on TSN, which I think it's an important aspect. But so it is supported, for real. Okay, then question from Marco. So Marco thanks us for the talk. Thank you, Marco. And then two questions. So first one, do we have any requirements in terms of OS to ensure features such as container support and properties like determinism? Do we also plan to support virtualization? So do you want to take that?
So definitely we do have, so as Angelo has mentioned, so first of all, at TTTech, one of our core knowledge and core IP is in area of scheduling. And when we talk about the scheduling, we talk about planning application, planning schedulers, and as well embedded assets that they cooperate closely with the operating system in order to ensure that that planning is being executed. And this is one of the key components and key assets that motion-wise, that is TTTech Auto product, that's a safety middleware. This is kind of the main core in order to make that happen. And as Angelo has mentioned, so here we have different aspects. So we will integrate DDS as part of motion-wise. Therefore, a user that will use MotionWise will leverage everything that we have been doing or we are doing together with ZettaScale, and as well we'll have DDS as a product. And as well, we are working in different products in order to be able to have a scalable consumption, so to say, from the communication perspective, from the scaling perspective, and the total platform or the total middleware. So the answer, Marco, is yes. With regards to container support, today we are not seeing it. So definitely container is something that we are acknowledging that it will come, but we need to make sure that we do embrace it at the proper time. And with regards to virtualization, definitely as well, we are today, for example, in several mass production programs, we are embedding, for example, in this case, it's MotionWise or our scaling capabilities in a hypervised system. And the second one, with regards to the complementary tool, what I wanted to make sure as well that at this point come across is the topic of tooling in the area of network configuration. It's not that much on the quality of QoS in terms of DDS, but what we want to do is to generate a valid network configuration of the Ethernet switch. So at the end, what we will do is to have the valid configuration on the endpoint that will be in order to be able to make sure that we make the proper serving of the datagram, so to say, but also we will generate a valid Ethernet switch configuration that is compliant with the overall configuration of the different endpoints. And this is something that we feel that is pretty unique, because this is basically what enables us is to speed and to boost the overall development cycles.
Yeah, and I think there is another aspect on that. So the DDS angle is that in DDS you have 22 QoS, okay? And maybe you'll say, wow, 22 QoS, how on earth am I supposed to use those? And some of those are kind of false friends, because all of a sudden you think that reliability QoS really is about reliability, but in fact, after using DDS, you realize that, actually reliability, the way in which I think about it, is a combination of reliability and history depth, okay? So long story short, when we typically, with our user, with our customer, we say, look, forget this 22 QoS because you are going to blow your mind. The reality is that there are clusters of QoS and there are patterns of QoS that make sense because they help you model certain kind of data. And so typically, we give 3 examples. You have soft state, hard state, and events. And, we typically have different QoS settings for each of those. And even with respect to certification, the way in which we are tackling certification is to make sure that there are well-defined QoS patterns that are used with certain kind of traffic, right, that are recommended for use, that are used to guide how you attach QoS to your data flow, and that have some user-level semantics, okay? So there is also some work that we are doing, which I think is very important, because otherwise, I mean, many people, and it's not really their job, right? Why do I need to understand 22 QoS? I mean, tell me how I should use QoS to express soft state or hard state, or Then there is a question concerning support for TSN. So we do have support for TSN, PCI Express. I mean, honestly, right now we don't support, but I can tell you that we have had project in the past, and that project was actually a very interesting project on a drone, which had 8 cameras connected over PCI Express. But in that case, what we were doing was to use DDS as a control plane and to set up RDMA over PCI Express. Okay, so that maybe could give you an idea. But adding support for PCI Express, honestly.
What I can tell you, Angelo, is, for example, on our side on TTTech Auto, we're working already with PCI Express. So in high performance compute in automotive, we see a hybrid backbone. So we see an Ethernet base and together with PCI Express. And in PCI Express, TTTech is working, we are working our own PCI Express infrastructure that will go all high to the overall higher level. And as well with PCI Express, what we are making sure is that PCI Express is working well, because PCI Express, it gives you a huge resource of bandwidth at the physical layer. but we might face problems as soon as we do hit software. So at the end, what we are working is in our own PCI Express infrastructure in order to be able to get rid of that bottleneck. And as well, one of the things that we are internally considering is how do we hook it up together with DDS.
Yeah. Okay, and so to answer another question from Angelo, we do have requests. I mean, I think we had a customer request yesterday on PCI Express support. So you can expect that PCI Express support will pop up either on Zen or on DDS, okay? Because we are receiving requests for both technologies. I think the last one we got on Zen was kind of yesterday, and we're getting some question on DDS today. So you see, it's a recurring theme. Other question from her, how many QS settings do we support right now? Well, we support all the QS, okay? Then for the certification, there is only a subset of QS that makes sense, but that no, we can detail aside. Important clarification. I'll let you take this. So from Nicola, which is asking, which AC level are we targeting, Salva, for the ISO 26216?
So we're targeting up to ACD, okay? So that means from the overall process, we are fulfilling the process in order to be able to be up to ACD. Definitely, DDS is being deployed in an SoC, and usually those SoCs are up to ACP. And as well, one of the things that I wanted to make sure is that when we are working on is towards the lighthouse of having ACD, let me call it, perhaps it's not 100% correct, the term that I'm going to use, but to be suitable to be deployed on failure operational systems. So at the end, we are taking the first step with having that ACD, but with the last resort of having it ready for failure operational systems.
Okay, and then there is another question which I believe we have answered, but I just want to make sure. The question is from Sven. He's asking if there is a tool to auto-generate real-time config for Cyclone DDS. I think that was somewhat answered by you with respect to the network configuration, and to some extent answered by me with respect to the QS patterns. And then, Sven, if you're referring to the specifics of the network stack configuration on Cyclone, well, that will be potentially one of the consequences of the tool for configuring the network. Okay. Let's see. So I'm scrolling again the questions. I believe we have answered the bulk of it. Let me double check. Okay, so there is a question on interoperability with other protocol. So again, for V2X, for V2X, I mean, at least as ZettaScale, we think that Zeno is the right approach, right? This is also what is being used for robotics for R2X. But again, this will be the subject probably of some other webinar, and we'll have time to discuss that in length. I believe we have answered all the questions. Salva, I don't know if you see anything I'm missing. I don't think so.
No, I do not see it, but anyhow, if there is any question that it pops up,
we'll follow up. Follow up. Okay, look, we are just on top of the hour, so perfect in time, and we're giving the example of being real time, predictable, deterministic. So 4 o'clock, we are done. Thank you, everyone, for joining. Salva, it was a great pleasure. We have to do
whenever you want. So this was my first time. So now, whenever you want, we can make it. We can repeat.
Great. Ale, ciao. Bye, everyone. Ciao, ciao.